Hi everyone, let me start my talk. My talk is Koalas, making an easy transition from Pandas to Apache Spark. I'm Takuya Shin, a software engineer at Databricks. I'm an Apache Spark committer and a PMC member. My focus is on Spark SQL internal and PySpark. And now I'm mainly working on Koalas project and one of the major contributors and maintainers. In this talk, I'll introduce Koalas and its purpose comparing to Pandas and PySpark. Next, I'll introduce Koalas 1.0. I'll show some demos related from basic to Koalas 1.0 related topics. Then I will explain an internal structure and a couple of important topics, which are about index and default index. Finally, let's see the roadmap after Koalas 1.0. What is Koalas? Koalas was announced on April 24th at last year's Spark AI Summit. It is a pure Python library and aims at providing Pandas APIs on top of Apache Spark. It's trying to unify the two ecosystems with a familiar API and to help to make a seamless transition between small and large data. For Pandas users, it will help to scale out the Pandas code and make learning PySpark much easier. And for PySpark users, it will provide more productive by its Pandas-like functions. Let's review what Pandas is. Pandas was authored by Wes McKinney in 2008. Pandas is the standard tool for data manipulation and analysis in Python. The latest version is 1.0.4. It's still growing, as you can see in the Stack Overflow trends. Pandas is deeply integrated into Python data science ecosystem, such as NumPy, Matplotlib, scikit-learn, and so on. It can deal with a lot of different situations, including basic statistical analysis, handling missing data, time series, categorical variables, strings, and so on. Python data scientists tend to start learning how to analyze data with Pandas and use it for work at first as well. Pandas works really well for small datasets in a single node, but unfortunately, it doesn't work well with bigger datasets. The data scientists have to learn PySpark or other libraries if they want to handle bigger datasets. On the other hand, what is Spark? As you know, Spark is a de facto standard unified analytics engine for large-scale data processing. It supports streaming, ETL, machine learning, and so on. Spark was originally created at UC Berkeley by Databricks founders. It provides PySpark API for Python as well as APIs for Scala, R, and SQL. The latest version is 3.0. Both Pandas and PySpark have concept of data frame. They look sometimes similar, but are actually significantly different. Only referring a column is the same in this table, but the others are different. You can see a lot of differences, but two most significant differences are its mutability and execution model. Pandas data frame can change its state directly, whereas Spark data frame doesn't allow to change the state, and we need to create a new data frame instead. Execution model is also different. Pandas computes its data eagerly, whereas Spark lazily, meaning it doesn't execute any computations until it actually needs, for example, showing or storing the data. Let's see a short example. The left side is Pandas, and the right side is PySpark. Both are doing the same thing, but the appearance is different. Pandas users have to learn PySpark to fill the gap between Pandas data frame and PySpark data frame if they want to handle bigger dataset. If there is Koalas, we can write almost the same as Pandas. Only things we have to do are to change the import and use the alias instead of Pandas 1. It's so cool, isn't it? The execution is lazy as the same as Spark data frame. Basically, it won't run Spark job until the actual data is needed. And the optimization of Spark data frame will be used during the execution. Thankfully, Koalas has been growing more and more. According to PyPI statistics, the download number reached 30,000 per day and 800,000 last month. And GitHub starts reached 2,000. Now we are hitting a big milestone. You know what? It's Koalas 1.0. It supports Spark 3.0 and optimizes some functions using Spark 3.0 functions. Data frame apply or data frame apply batch functions will be optimized with Spark's mapping pandas function, which improves the performance 20 to 25% faster. Also, it supports Pandas 1.0. Actually, we started supporting it since Koalas 0.28.0, but basically, Koalas follows Pandas 1.0 behavior from now on. We removed duplicated functions, which are removed in Pandas 1.0, or a couple of Koalas functions. On the other hand, we introduced Spark property to correct Spark-specific functions in it. The Pandas API coverage is increasing over time. Series and data frame APIs are more than 70%, and index and group by functions are 60% range. Also, 80% of plot functions are already implemented.
I'll show you simple demos here. At first, of course, we should import Koalas. The package name is databricks.koalas, and usually we use KS as an alias name. These short examples were on the slides. We can just confirm that the example actually works and shows exactly the same result. The next example is how to convert from or to Pandas data frame. To convert from Pandas data frame, we can use from Pandas function. It moves the data to Spark data frame and manages some metadata to behave as Pandas data frame. To convert back to Pandas data frame, we can use toPandas function. Next, we also have to know how to convert from or to Spark data frame. When importing Koalas package, it automatically attaches to Koalas function onto Spark data frame, so we can use it. As Koalas manages index columns, we can see an additional columns here. To back to Spark data frame, we can use toSpark function similar to toPandas. If we have columns to be used as index, we can use index col parameter. Then Koalas uses the columns as index. If the columns are more than one, we can use list. When going back to Spark data frame, if we want to preserve the index values, we can also use index column parameter. We can also use list, but the length must be the same as the number of index columns. Let's see more simple examples. Here it shows main function. This is for data frame and this is for series. We have more and more statistics functions from Pandas. If we want a summary, we can call describe function. Of course, we have group by functions. This example shows group by sum function, but we also have more and more group by functions. Also plotting. Both series and data frame have plot functions. The default is line plot. We already implemented 80% of plot functions. More and more examples are available in the blog post, 10 minutes from Pandas to Koalas on Apache Spark. Please take a look at the blog post. The next shows transform and apply functions. From Pandas, Koalas has transform and apply functions to apply a function against Koalas data frame. The differences between transform and apply is that transform requires to return the same length as the input, whereas apply doesn't require it. Each function takes a Pandas series. Koalas also has transform batch and apply batch functions. The batch postfix means each chunk in Koalas data frame or series. This slices the Koalas data frame or series and applies the given functions. For data frame, each function takes a Pandas data frame, and for series, it takes a Pandas series. Here, transform batch has the length restriction, whereas apply batch does not, as same as transform and apply. The next section is for Spark users. Since Koalas 1.0, it provides Spark property. The first example is to know the underlying Spark schema and data types. Schema function returns a strict type object of Spark, and print schema prints out its schema as a tree string. Both take index color parameter to include the index columns. For series and index, data type function gives the data type. The next one is dataframe Spark apply. It runs the given UDF, which takes a Spark dataframe. We can modify the underlying Spark dataframe as we want. If we want to preserve index columns, it also takes index column parameter. We can modify the index values, but the returning Spark dataframe also has to include columns with the same names. Similarly, for series, it provides transform function. The UDF takes Spark column object, and we can modify it with Spark functions. The final example is explain. We can check the underlying Spark planning.
Well, let's go back to the slides. Here, let me explain a bit of Koalas internal. Koalas basic structure is like this. Koalas data frame has internal frame in it. Internal frame is immutable structure, and it holds the current Spark data frame and some metadata, such as column levels and index map, to provide a good mimic of Pandas data frame. If a user calls some API, Koalas data frame creates a new Spark data frame and updates the metadata in internal frame. Creates or copies the current internal frame with the new state, then return a new Koalas data frame. Sometimes the new Spark data frame is not needed, but only the updates of metadata. Then new structure will be like this. In any case, Koalas data frame never mutates internal frame, but creates or copies the internal frame to keep it immutable. Next topics, index and default index. As you saw in the demo, Koalas manages a group of columns as indexes, and they should behave the same as Pandas. When you have Pandas data frame and convert it to Koalas from Pandas function, then Koalas automatically picks up and builds its metadata. But other data sources, like Spark data frame, don't always have an index. What if the index is not specified? Koalas will automatically attach a default index to the data frame. Koalas provides 3 types of default index. Each default index has pros and cons. We need to decide which index we should use carefully. The three index types are sequence, distributed sequence, and distributed. The sequence is the default value. This guarantees the index increments continuously, but it uses no partition window function internally. It means all the data need to be collected into a single node. If the node doesn't have enough memory, out-of-memory error will occur. The second option is distributed sequence. Once the index is attached, the performance penalty is not as significant as sequence type. It computes and generates the index in the distributed manner, but it needs another extra Spark job to generate the global sequence internally. Also notice that in some cases, it doesn't guarantee continuously increasing number. The third option is distributed. It has almost no performance penalty and always creates different numbers. But the numbers have an indeterministic gap. It means this index type can never be used as indexes for operations on different data frames. But if the index is just needed to order rows, then this index type would be the best choice. Please also see the user guide for more detail. Finally, I show the roadmap after Koalas 1.0. In July or August of this year, Databricks Runtime 7.1 will be released, which will pre-install Koalas 1.x, the stable release of that time. We continue improving the Pandas API coverage and support more visualization or machine learning libraries. Also, we add more examples in the documentation or workarounds for APIs we won't support. Well, please get started soon. You can install Koalas by PIP or Conda. If you don't have a Spark cluster yet, you can also install PySpark with PIP or Conda for your local computers. Also, please take a look at the documents and follow updates on GitHub. There is 10 minutes tutorial in a live Jupyter notebook available. You can also easily import it into Databricks notebook. There is a really useful blog post I mentioned during the demo. It shows a lot of examples as well as best practices. If you have any suggestions, questions, feature requests, please feel free to file an issue on the GitHub issue page. Your contributions are always welcome. Please take a look at the contribution guide. We will have another Koalas session from 10 a.m. on Friday, which will show more examples. Please join the session too.